Another one. Three cable forces, 1, 2, 3, act on this I bolt, determine the force P so that the resultant force has a magnitude of 800. Okay, now, things are getting apparently a little bit more difficult, but it's the same thing. How do you solve problems of summation of forces in 2D equilibrium for particles? Decompose the force in components. Find the components, find the resultant force in X, the resultant force in Y, the resultant force, and then solve for the unknowns. Which should be two, as I said before. Okay, what two unknowns we have? We don't know the value for P, but we know the direction. And we know the magnitude of the resultant force, but we don't know the direction. So we cannot assume, like in the previous problem, that the force was directed in the X direction or the Y direction, because it's not. So let's do this and let's solve it. Let's start first finding the resultant of the forces in the X direction. Let's start with this one. This one in the X is this component here. Remember, whenever you have this triangle, use it. This is 3 over 5 times 1000. 3 over 5 similar triangles over 5 times 1000. And it's negative because it's pointing opposite to whatever the X direction should be. Done with that one. This is not J, this is semicolon. The other one, this force of 400, this is the component, negative as well because it's pointing to the left. And it's going to be 400 cosine, remember, adjacent to the angle, 400 cosine 30. Plus P. That would be our resultant force in X. Let's do that, simplify that. This is going to be 600. This is negative 600, but let's do it. 3 out of 5 times 1000 minus 400 cosine 30. And that's syntax error. That's what you're going to copy here. Syntax error. Cosine 30. Why didn't you put here cosine 30? 253 is on minus. You see, I put minus here and I didn't put minus here. But I was keeping in mind that this number here was already 600, so it shouldn't be that value. Okay, anyway, 3 out of 5 times 1000 plus, I'm putting plus and plus because I'm passing them to the other side. Or I'm keeping them negative, it's okay. I'm putting the negative sign there, plus 400 cosine 30. So 946.41. So it's going to be P minus 946.41. That's the resultant in the X direction. Now the resultant in the Y direction. The resultant in the Y direction will be this component positive because it's pointing up 4/5 positive of 1000, and this other one is going in this direction, which is negative, pointing downward, negative 400 sine 30, and we can calculate the resultant in the Y direction. This is 800 minus 200, 600. 600. And now we use the other piece of information that we have, which is the magnitude of the resultant force is 800. And how do we calculate the magnitude of the resultant force? Remember, the magnitude of the resultant force is the square root of FRA or we can square both of them and we just get rid of that square root over there. So resultant force 800. 800 squared has to be equal to this P minus 946.41 squared plus 600 squared. And now we can solve this problem. I can pass this to the other side or pass this to this side, better said. So P minus 946.41 squared has to be equal to 800 squared minus 600 squared. And 800 squared minus 600 squared is 280,000. And then to get rid of this square, I just take the square root of this or elevate it to 0.5, which is the same thing, and that's 529.15. So now I get this P minus 946.41 has to be equal to plus or minus, remember it's the square root, 529.15. And the plus or minus is important because there's going to be a value that will make sense and a value that will not make sense. It could be two different values. I really I really don't know what is going to be the value. Let's see. If I solve for P, I'm going to get two values for P. The first value for P will be using the plus sign, and I pass this as a negative, as a positive to the other side. So it will be 529.15. I'm going to put the plus here just to indicate that it's a plus, 946.41. And the second value for P will be, this is out of focus. Why are you out of focus? Now you are in focus again, or I am getting out of focus. There you go. So it's going to be minus 529.15 plus, I'm using this one, 946.41. So for the first one, plus 946.41, that will be 1475.56 pounds. And the other possibility will be 946.41 minus 529.15. That will be equal to 417 pounds. Okay, what does this mean? This means that actually both of the values for the forces makes that problem, makes a viable solution for that problem. Now, for this case, you can leave it like that. You can say 1.48 keeps if you want to, but you can keep it like that. However, if the problem should state something else, like for example, the value for the force P should be between this and that values, and then you will select any of them accordingly to whatever. But there's no more constraints here, so whatever of these two values you use will be valid for the solution of the problem. I'm just thinking about what can happen here if, and that happens because this is a quadratic equation. So the equation is coming and it has two intersections of roots, or two roots, two valid roots for that. What would be the best solution? There's no such thing as a best solution here. There's just those two solutions. That's it. If the force is this, the resultant magnitude is going to be like that, then it's going to be changing as the force keeps increasing. This value will be increasing and the other one will be decreasing, but this is the value. That's it, nothing else. There's nothing else to discuss here unless we know an approximate direction of the resultant force. For example, you could say something like, oh, the resultant force is pointing upward and to the left, or upward and to the right. Then only one of them will be making sense to be the solution. But for this problem stated in the way that it is, this is the solution. Solutions, both of them. Thank you for watching.